The moment you step inside a modern industrial factory, the scale of everything changes. What looks ordinary from the outside hides an enormous, carefully synchronized world inside, where thousands of tons of raw material are transformed every eye. Single day. The air carries a constant hum, not noise, but rhythm. The sound of machines working together with precision that never sleeps. This is not just manufacturing. This is industrial choreography, where speed, cleanliness, and accuracy decide everything. At the very beginning of the process, massive shipments of raw materials arrive from different regions, sometimes even different countries. These materials are unloaded with powerful automated cranes and conveyor systems designed to handle extreme weight without slowing down. Every batch is logged digitally, scanned, weighed, and tested before it even enters the production line. Nothing moves forward without passing quality checkpoints. Sensors analyze moisture levels, density, composition, and temperature, ensuring consistency from the first second. Once approved, the materials flow into gigantic storage silos or sealed containers. These structures are engineered to preserve quality while allowing precise control over release. Instead of human hands, automated gates open and close, feeding exact quantities into the system. Even a small deviation can affect thousands of tons later, which is why precision here is non-negotiable. As the materials enter the processing phase, the factory truly comes alive. Conveyor belts stretch for hundreds of meters, carrying raw inputs. Through different stages, each belt moves at a calculated speed, adjusted in real time by artificial intelligence. Cameras and laser scanners monitor the surface, shape, and movement, instantly detecting irregularities. If something looks even, slightly off, the system reacts faster than any human could. Heavy-duty machines begin the core transformation. Crushing, cutting, melting, mixing, or refining happens inside sealed units designed for maximum efficiency. These machines operate under extreme conditions, intense heat, immense pressure, or rapid motion, yet they remain controlled to the smallest detail. Advanced cooling systems prevent overheating, while internal sensors constantly measure output quality. What makes modern factories extraordinary is automation. Robotic arms move with mechanical grace, performing repetitive tasks flawlessly. They lift, rotate, slice, assemble, and transport without fatigue. Unlike older factories, where human error was unavoidable, these systems maintain the same accuracy. Hour after hour, day after day. Humans are still present, but their role has shifted from manual labor to supervision, programming, and optimization. As processing continues, materials pass through multiple refinement stages. Impurities are filtered out using advanced separation technologies. Magnetic fields, air pressure systems, and precision screens remove unwanted elements. This ensures that by the time the product moves forward, it meets strict industrial standards. Every step leaves a digital footprint, allowing complete traceability from raw input to finished output. Temperature control plays a critical role throughout the factory. Massive heating chambers raise materials to exact degrees, while rapid cooling systems lock in structural integrity. Too hot or too cold, and the entire batch could be compromised. This balance is maintained through automated feedback loops. where machines adjust themselves in real time based on sensor data. Energy management is another hidden marvel. Processing thousands of tons requires enormous power, but modern factories are designed to minimize waste. Heat generated in one section is recycled to power another. Smart grids distribute electricity only when needed, reducing overload and saving energy. Sustainability is no longer optional. It is engineered into the system. As the processed material moves closer to completion, shaping and finishing begin. Machines mold, compress, or refine the product into its final industrial form. The speed here is astonishing. What once took hours can now happen in minutes. Yet, despite the speed, accuracy remains absolute. Tolerances are measured in microns, far beyond human perception. Quality control is constant, not occasional. High-resolution cameras capture thousands of images per second, comparing each product against ideal digital models. Any deviation triggers automatic rejection. Defective items are removed instantly, recycled back into the system, or flagged for analysis. This closed-loop system ensures continuous improvement. Packaging at industrial scale is a process of its own. Finished products move into automated packaging zones where machines wrap, seal, label, and stack with perfect alignment. Barcodes and tracking chips are applied to each unit, enabling global tracking once the product leaves the factory. Even the packaging materials are optimized for durability and environmental impact. Logistics integration is seamless. As products are packaged, inventory systems update in real time. Shipping schedules adjust automatically based on demand. Trucks, trains, or ships are loaded with robotic precision, maximizing space and minimizing handling time. From factory floor to global distribution, everything is synchronized. Behind all this machinery lies a powerful digital brain. Control rooms filled with screens display live data from every corner of the factory. Engineers monitor performance, metrics, energy usage, output quality, and maintenance needs. Predictive systems alert teams before failures occur, allowing repairs without stopping production. Downtime is the enemy, and modern factories are designed to avoid it at all costs. Safety is built into every layer. Automated systems reduce human exposure to dangerous environments. When people do enter production zones, sensors track their movement, slowing or stopping machines if necessary. Emergency protocols are programmed, tested, and refined continuously. Industrial scale does not mean industrial risk. It means industrial control. Maintenance itself has evolved. Instead of waiting for machines to break, sensors monitor vibration, sound, and temperature to predict wear. Components are replaced before failure, extending lifespan and maintaining efficiency. This predictive approach saves millions in costs and prevents massive disruptions. Waste management is another crucial element. Byproducts are collected, sorted, and either reused or treated responsibly. Many modern factories aim for near-zero waste, turning what was once discarded into valuable secondary materials. This not only reduces environmental impact, but also improves profitability. What truly defines industrial-scale processing is continuity. Production does not stop. Shifts change, but machines keep running. Lights may dim, but systems remain active. This 24/7 operation is what allows thousands of tons to be processed consistently, reliably, and at a global scale. From the outside, the final product may seem simple, but behind it lies a complex network of technology, engineering, and planning. Every second, every movement, every calculation contributes to a system designed for one purpose: efficiency at scale. Modern factories represent the peak of human ingenuity applied to production. They combine mechanical power with digital intelligence, transforming raw materials into essential products that support everyday life. What happens inside these walls is not just manufacturing. It is the backbone of the modern world, operating quietly, relentlessly, and with astonishing precision. And as technology continues to evolve, these factories will only become smarter, faster, and more sustainable. The future of industrial processing is already here, running smoothly behind closed doors, turning thousands of tons into progress every single day.